All right, well, here today we're starting with 2.5, proving statements about segments. Now, this is probably one of the toughest sections. Well, this is where it really gets tough for a lot of people, but um, I think if you really try, if you need to go through and watch these examples again at the end or whatever you need to do, it's going to pay off. But first, we have a vocabulary word for you, theorem. A theorem is a true statement. Okay, so it's a true statement that follows from other true statements. And so we've taken accepted statements like postulates, and we've used definitions, and we're going to use those to come up with theorems that follow from those statements. So properties of segments and congruence. Here's our first theorem of our book, and it's basically, if you've seen the words reflexive, symmetric, and transitive before, well, now we're going to apply those um, definitions or properties from for lengths, right? They were this segment length equals this segment, or this angle measure equals that one for segments now. So, like, for example, the reflexive property, I have segment AB, right? The difference now is the lines above. Other than that, it's pretty much the same. Segment AB is going to be congruent to segment AB. So that's true for any segment AB. It's congruent to itself. The symmetric property, so that was our guy pulling on his cheeks. The symmetric property, the two frogs look pretty symmetric. If segment AB is congruent to segment CD, then CD is going to be congruent to segment AB. So same properties as before, but now we're saying for segments. Okay, that's the only difference. Transitive property, if segment AB is congruent to segment CD and segment CD is congruent to segment EF, okay, followed by the transitive property then that segment AB is congruent to segment EF. Okay, so now we got just a bunch of examples. We got, I think, 4 examples today and they're just all proofs. Okay, and this is where people really tend to struggle, is doing a proof, especially when you have to do the statement. So notice I'm given something. I want to start my proof with that given. Okay, what am I given? Here's my statement that the length of EF, or the distance of EF, equals the distance of GH. I'm given that. Okay, so my reason, remember 90% of your proofs are going to start with the reason given. It'd be an easy way to see who's watching their videos if they can know how to start your proofs, right? Getting started is, half the battle usually. And I look at this and I see that I want to prove something about the segments are congruent. So when I have the length of EF equaling the length of GH, I would like to get into saying that those segments were congruent. Okay, so I want to show that the segments, segment is congruent to GH at some point. Actually, I'm probably gonna hold off on that too a little bit later. We'll come back to that. Here we go. Let's instead say I see EF. It's important to use your pictures, EF and GH. I'm going to use, and I want to prove that EG, this is congruent to that, right? So This FG is in the middle. So I'm going to take this EF plus GH and I'm going to add the same thing to it. I'm going to add FG to both sides. I'm going to take GH and add FG as well. Okay, so that's going to start to give us this whole segment, and that's what they want us to prove, that these segments are congruent. So adding those together, why can we do that? That's the addition property of equality. From here, I would like so right now EF plus FG. Well, I'd like to know something about EG. What does EG equal? Well, EG is these two parts, right? EF plus FG. EF plus FG. That's what EG equals. And I also want to know something about FH. I know FH is the sum of FG and GH. So FH is equal to FG plus GH. So what says I can add two segments together? It's a segment addition postulate. So we're using the diagram to come up with this piece of information. So number 2, to come up with number 2, we use statement 1. Statement 2 followed from statement 1. Statement 3 is kind of its own thing right now. It came from the picture. Statement 4 is going to be that EG equals FH. Because that's getting pretty close to what I want to prove. EG congruent to FH. Well, right now I can say they're equal to each other. And that is because, get another color out here. This is kind of like that proof from yesterday. EG is equal to EF plus FG. EF plus FG is equal to GH. GH plus FG. That's the same thing as here, GH plus FG. And that is the same as FH. So if you follow those arrows, all these things, so when they're not on the same line, they're the same thing. So this is the same as that, this is the same as that. But EG equals this, which equals that, which equals this. So that is a substitution of equality. And number 5, from here, what I'm trying to prove, so now I showed that the lengths are the same. So if the lengths are the same, what is that? Why can we say that the segments are then congruent? And these are segments, so it's important to put those over here. The lengths are the same. Why are the segments congruent? If you remember the definition of congruence, the definition of congruence says they have the same measure for angles and same length for segments. So definition of congruence works basically both ways. If they have the same length, then they're congruent, and if they're congruent, they have the same length. So whenever you see a congruent sign go to an equal sign, that is always the definition of congruence. Okay, so that's important to know whenever you see an improvement, an equal sign go into a congruent sign. The reason is the definition of congruence. Complete this proof. That's the directions. They give us a picture And what else do they give us other than the picture? Okay, they also give us these two things, right? That segment RT, this whole segment, is congruent to WY, this whole segment. The length of ST is the same as the length of WX. So as we start to prove that RS is congruent to XY, if we start to prove that, here we're going to fill in the blanks, and this is how some of your homework problems go. You just have to fill in some of the reasons and some of the statements. So the first statement they want us to use is a given, right? So we're given three things, basically, this, and the picture. Usually when it's a picture, if you're taking something off of that, it'll be a postulate, like the segment addition postulate, but here it's a given, so it's one of these two things. So I have to look down here and see what my next statement is. My next statement is RT equals WY. So I look at this, RT is congruent to WY. Maybe I should start with that. So segment RT is congruent to WY. That was a given. Now, what makes us say that RT equals WY? We go from a congruent sign to an equal sign. Okay, that's the definition of congruence once again. Okay, whenever you switch from congruent sign to equal sign, definition of congruence. Now, RT equals RS plus ST. Is that one of my givens? No, so that's not the reason. So maybe let's look at the picture. RT equals RS plus ST. RS plus ST equals RT. I'm adding two segments together to get a total segment. What property could that be? WY is equal to WX plus XY. WX plus XY. Add these two segments together to get the total segment. That's a postulate. What postulate is it? That is your segment addition postulate. Okay. Now they want us to do a substitution. You see a substitution we could probably make. So I'm looking at, could I maybe substitute a WY for an RT somewhere? Could I take a WY and substitute it in, and is that going to help me on my next thing? Where are we going with this, right? We want to get down to, our final congruence thing, but we want to get to segment RS being congruent to segment XY. So by doing this substitution, and this is where it just takes practice, I'm gonna be able to say RT equals WX plus XY. So now I'll just make sure I'm going the right way here. I'm thinking about it. It's a thought process, guys. So you don't expect. Even I have to stop and think and make sure I'm going the right way. And I'm thinking, I'm going to adjust this a little bit. We're still going to do a substitution, but I'm gonna get a little bit closer to my end goal. I'm going to go right to saying that these two things are equal to each other. So I was kind of looking at, how the rest of this was going to play out. Since these things are equal to each other, right? That means WX plus XY has to equal RS plus ST. Those are equal. From there, there's RS, WX, and ST, WX. All right, so sorry about the pause. I think since I did the substitution in one step, and that kind of eliminated the need for step 5. Sometimes that happens. You can come up with a faster way of proving something. Sometimes you need that step. You can't just skip over it. But in this case, I'm looking at this, and I'm going to go. I'm just going to go and use this fact: ST equals WX. Now, I'm not always just going from this line to this line, right? Sometimes I'm using something from the picture to start a new train of thought. And in this case, I haven't used this given yet, ST equals WX. As I come down here, ST equals WX. Reason for that is that's one of my givens. I'm using that second given now. Okay, so I use my first given, I use that segment addition postulate from the picture, using another given, and now it's going to work a little bit better because I have ST over here, right, and WX right here. So how do I get XY and RS by themselves? XY equaling RS? Well, if these things are equal to each other, I can subtract those. Okay, the subtraction property of equality. Right? Subtraction property of equality says I can subtract the same thing from both sides. Well, WX and ST, they're the same, right? So I'm subtracting those from both sides of this equation up here in line 4 to get that RS equals XY. And what are we trying to prove? Every single time our proof ends with what we're trying to prove. That's when you're done. So we're trying to prove that segment RS is congruent to segment XY. Segment RS is congruent to segment XY. That's what we're trying to prove, and why does it follow? That's the definition of congruence. Okay? We've been using that every single time that an equal sign goes to a congruent sign. Definition of congruent segments. Video is getting kind of long already, so I'm going to try to just walk through example 3. When you're given that x is a midpoint, you could start with that given. Okay, so you have your reasons, and here I don't even have a thing set up for you. Excuse me, that shouldn't be reasons. I'm trying to hustle too much and I make mistakes. That happens. You have your statement and your reasons. Okay, so you'll have to set up some proofs on your own. And your first statement would be your givens. Okay, sometimes you can state them all at once, or sometimes you'll break them into part. So if x is the midpoint of mn, what does the definition of midpoint tell us? So you'd state with that given, but then you could use that definition of midpoint to say that segment mx is congruent to segment xn. We know that mx equals rx. So the length of mx equals rx. So we know those lengths are equal, so you could use the definition of congruence to show that those segments are equal. And then we want to prove that xn equals rx. And if this equals this, and this equals that, why does this equal this? Okay, so this and that are equal. This and that are equal. So why are these things equal? That's that transitive property. Transitive property of segment congruence. So that wasn't a formal proof. You could turn that into a formal proof pretty easily. And then this one, I'm just going to they want us to find BC. So in the diagram, AB is congruent to BC, and BC is congruent to CD. Okay, so this is congruent to that. This is congruent to this. So how can I set this equation up? I know that this and this have to be equal because of that transitive property. So if I'm going to find BC, I want to find what one of these segments are. So I'm going to say 3x minus 1. That's the same thing as 2x plus 3. I'll subtract 2x from both sides because I want to get my x's to one side. I get x minus 1 equals 3. Add 1 to both sides. I get x equals 4. Now, is that my answer? Did I find BC? No, I found what x was. So I could put 4 in for x, and I'd get 3 times 4 minus 1, which is 12 minus 1. So AB has a length of 11. And since they're congruent, I know that their lengths have to be equal. So I think the length of BC is going to equal 11. That is my answer. Here's your homework assignment. That lesson was a little bit long, but I write this down, and hopefully you get to ask a lot of these questions, because proving stuff is really, really tough. Okay, so it just takes a lot of practice, and if you don't get that practice, you'll never get it. Okay, so it's important that you practice now while the concepts are still kind of on the easier side. They're just going to get a lot more complicated in the chapters to come. Have a good night, everybody.